Hello, my beautiful computer science students. Welcome to another lesson in Unit 3 class creation of our AP CSA course. If you're new here, I'm Goldie and I'm here to take you through everything AP Computer Science A. In this lesson, we're going to go over accessor and mutator methods in an object creating class. So up until this point, we've talked about constructors and we've talked about some special methods that we can implement in our object creating classes to help us define an object. And now we're going to talk about accessor and mutator methods. So we've created instance variables, and now we're going to talk about how to access instance variables and mutate them when we are promoting encapsulation here. So we're going to go over how to write all of those today. Okay? So we're going to start off first with accessor methods. Now, we can't access private instance variables directly. We can't just use the object reference, dot, and then the variable name. Now, we could do this if it was a public instance variable, but we've said since the beginning, since we introduced instance variables, we always want to make them private to promote encapsulation and data protection. So while this would be valid code if they were public, it is not going to work because we have private instance variables. So if we want the ability to access them, and when we talk about access, we usually want to view what those variables are holding at any specific moment in our program. So if we want to view their contents, you have to create a public method, and then you can call on the public method to access those private instance variables. Because remember, when they're private instance variables, they're just private to outside classes, right? You can use them anywhere in your object creating class, but being private means that outside classes can't access them. Okay? So we're going to make a public method, and that public method, because it's going to be located in the same class, it's going to be able to see that instance variable, and because it's public, it's going to be able to be called on by an outside class. Okay? So that's why we're going to make this kind of intermediary method to be able to access our data. Okay? So we call these accessor methods, or another term would be a getter. Okay? So we call them a getter because they allow us to get and access our instance variables. Okay? So it allows an object to obtain the value of the instance variable at that moment in time. Okay? So they have the following properties that we're going to create here. They are public because we want other classes to be able to call on them. The return type is going to match the type of the instance variable it is returning. The naming convention, again, naming conventions are just agreed upon nomenclature in the CSA world for Java. You don't have to have it called this in order for it to run and for it to function properly, but you're going to want to follow this in order to kind of match what everyone else is doing. Okay. The convention is to use the word get, lowercase g, followed by the instance variable name, whatever that instance variable name is, using camel case where appropriate, and then an empty parameter set after that. There are going to be no parameters for an accessor method. The only thing inside the method is going to be a single line that returns the variable name, whatever that instance variable is. Okay. So here we're going to write our accessor methods from our dog class in lesson 1. So if you haven't seen that, we actually introduced dog class way back in unit 1. We revisited it in lesson 1 when we kind of refreshed our memory on constructors and all of the methods and stuff. So here's just a partial class of that again. Okay, so we're not going to go over the constructors again. Know that they are there. And this is also sometimes how the AP exam likes to give you larger classes as well, both in the multiple choice and sometimes even in the free response. They'll put in a statement here, commented out, where it says constructors and other methods not shown. So we know we've made the dog class before. We know that we have constructors and other methods. It's just a lot to include every time we revisit it. Ooh, if I can get that out right. Every time we revisit it, it's hard to get out. So constructors and other methods, we just don't show them here, but you can assume that they're part of the class. Okay. I did include the instance variables. We have 3 instance variables for our dog that we've been talking about. We have name, private string name, private int age, and private Boolean good dog. So we're going to make 3 accessor methods. We need to make accessor for each of our instance variables. So three instance variables means three accessors, okay? So we start off, this is gonna be the body of the method. It's a public string get name empty parameter set. So this is going to be to retrieve name from our object, from our dog that we create, okay? So public string get name, empty parameter set, and then we return name, okay? And that's one of the accessors, okay? The other two are gonna follow this same template. Okay. Name was a string, so we returned a string. When we want to do age, we return an age. So that's going to be public int now because we're returning an integer variable, and then get age. Again, empty parameter set, and all we do is we return age. Okay. And then last one for the good dog, public boolean, we're returning a boolean, get good dog, and then just return good dog. So we have an accessor for each of our instance variables. And so whatever dog we end up creating, we can always see the data at any point by calling on these accessors. So for example, okay, consider the following segment of code which appears in a class other than dog. So I include these instructions as well because this is, again, kind of the wording they use on the AP exam. When they say which appears in a class other than dog, they mean they construct the object outside, and now they want to either access, modify, whatever with the dog's data. And in order to do that, again, because we have encapsulation rules here, in order to do that, you have to have accessors, and eventually later on in this lesson, you have to have mutators, right? So here I have dog, doggy equals new dog, and I use my parameter constructor. This is going to be the name, the age, and if they're a good dog or not. So Scrappy is not a good dog right now, okay? He's 2 years old, and his name's Scrappy. And here's his reference variable right here. So in order to access any of the data, I have to use doggy.getName. So here, doggy.getName says, okay, doggy is a dog object, so go to the dog class, look for the method called getName, and return name, okay? What are you returning? Well, you're returning the name of the reference that called it, okay? And the reference that called it, doggy, the name is Scrappy. So this is gonna print off Scrappy, all right? Now again, if name was public, okay, and to be public, you either put public where I start instead of private, or you just don't put it at all, okay? By default, if you don't put an identifier out there, it is just going to be public. If you had doggy, if it was public, you could do doggy.name, okay, and then it would print Scrappy, okay? But again, when it's not private, you're not doing encapsulation correctly, okay? And encapsulation is a pillar of object-oriented programming because it protects data, right? And I know it seems a little like, oh, great, we want to protect the data. You know, protect the data, okay? You don't want to change it. You want to have control over what changes it and when it gets changed, right? So right now it seems a little bit like a extra step that you don't need, and that's because we're learning about it, right? We don't really see the power of it until you get into those larger programs. So just trust me when I want to say you want to have everything private when it comes to your instance variables, okay? You don't want to be able to do this, okay? All right, let's talk about toString method now. So toString is an overridden method that is included in classes to provide a description of a specific object. As of 2025 CED for the AP CSA course, they no longer want or require you to override the toString method, okay? And mostly that's because inheritance is no longer covered in the course, right? But that's okay. I still want to include it so that if you use toString, you kind of know what you're doing, okay? So I'm going to put it here. Now, the reason we have a toString method override is because there's actually this thing called the object superclass. And the object superclass is the class that all classes we create inherit properties from. Okay? And again, we don't cover inheritance anymore, so you don't quite know what that means, but it's just like this overlord, right? And when we make a new class, the new class can use any method in that object's superclass. One of the methods that it has is a toString method, okay? Now, if you make your own toString method, like in our dog class that we're about to do, when you make your own toString method, you're able to return a string of the instance variables. And what that does for you, it allows you to return the data all at once of your object, formatted in a way that suits your program's needs. Okay? It's a convenient method to have when you want to know, okay, what is this object's data all at once? Whether you want to, usually you want to display it, right? Or check the contents at whatever point in your program. So I think it's a good method to include. So we're going to look at it, okay? It has the following properties. It's public because other classes you want to be able to call on it, and it returns a string. It does not print off anything. It returns a string, and then usually you print off that string in your main driver class, but the toString method itself in your object class just returns a string. It accepts no parameters, and in its body you can have a single return statement that returns a string, or you can also declare a few strings and then kind of concatenate them all together at the end. And I'm going to show you an example of each of the ways we do that, okay? So here are the two options we could do for a dog. Here's all in one line option. So it's called public string toString. You see that I have return, and then I'm going to return this whole thing, okay? What is this whole thing? Well, I return the name plus a space plus the age, and then I have dot is name a good dog, and then I return the contents of good dog, whether that's true or false. So you can see I have the data, right? Name, age, and good dog. That's all of the instance variable values at any moment when you call on toString. It's going to return, put in that space what the data's value is at that moment in the program, okay? And then everything else, I use name again here. Everything else like this, and this is all just part of the string, okay? So remember, when you concatenate strings with non-strings, everything just becomes a string, right? So name's a string, but age and good dog, int and a Boolean, but when you put it all together with a string, it just becomes one giant string. So this is a giant string that gets returned to wherever is calling the toString method. Okay. Another way, this is a second way, okay? You don't have to write both ways, just choose one way, okay? Choose one toString method that you like. Here's the other way, is if you want to be a little bit more, I don't know if it's more organized or just sometimes people's brains think like this, right? If I take string first, name plus age plus period, so basically the first sentence, and then I have string second is name a good dog plus good dog. And then I return first concatenated with the second, okay? So one sentence plus the second sentence, okay? Another way you could do it. In the toString, you can also put formatting for like new lines, like the \n. You can put tabs in there. You can put whatever in the toString in and return a string that basically formats the data and outputs it the way you want it to output. And then the way we would use it in a program, here's two ways. Okay. And again, note that these two ways, this is going to appear in a class other than dog when you do it. Okay. So the first way you see here, again, dog, doggy equals new dog, Scrappy. Okay. Scrappy's 2 and false. He's not a good dog. Okay. I can say print off doggy.toString. So this calls on the toString method in the doggy class. And what that's going to print, Scrappy 2. Is Scrappy a good dog? False. Okay, so remember that we printed off the name plus a space plus the age, and then I had this as part of my string. I printed off a name, a good dog, and then I printed off the result of good dog. Okay, so I printed off the information all in a nice format. Okay. All in nice format there. Another way, so we could do doggy.toString, or here's a fun fact. If you just put your reference variable inside that printline method, the printline method knows that when when it sees a reference in there, it knows it's automatically going to call on doggy's toString method. So fun fact, this also prints off the same thing. Okay? It knows, hey, I'm going to look for the toString method in the dog class. And when I find that toString method in the dog class, I'm going to get that string that it returns, and I'm going to print it off. Okay. Now, again, this automatically runs the toString method in the objects class. If the object does not have a toString method, it will print the memory location. And the reason it prints a memory location is it's because of inheritance, where, okay, I look in the dog class. If I don't see it in the dog class, I'm going to go up to my object class. I'm going to go up the ladder, and I'm going to go to the big guy upstairs here, and I'm going to run their toString method. And the object superclass, their toString method just returns the memory location, which for us is useless. We don't care about that, okay? Which is why usually we want to make a toString method in our object class to override that, okay? Because we don't care about the memory location. We care about what the data actually shows, okay? Again, not covered on the AP CSA exam anymore though. But now you know. The more you know, okay? And it is very helpful when you do have the larger objects and you're coding the larger object creation programs. You might want to end up including this because it does help to be able to see all the data at once. Okay, the last thing we're going to talk about in this lesson is mutator methods, okay? So in addition to not being able to view private instance variables and their data, you cannot modify them, okay? And you cannot modify them directly. So we can create an object with a constructor, but what happens after we create it with a constructor? What if we want to change that data in some way? Now, we've seen some methods we could write that actually do that. We've written methods that allowed us to change these instance variables. In addition to writing those, we can also write these mutator methods. And these mutator methods allow us to change the data with a variable. Okay. Now, if the instance variables were public, we could use the statement just kind of like we did with our accessors, where we use the object reference dot the variable name equals new value, and we can modify it. But our instance variables are not public, okay? We have to have an intermediary public method in order to change those instance variables, okay? And again, I know it seems like an extra step. Why do I want to make an intermediate method when I can just make public instance variables? It all comes back to encapsulation. You got to protect your data, and public methods in your object creating class are going to let you do that. So we're going to create another public method and use it to modify contents of an instance variable. So a mutator method is also called a setter. So we have getters and setters. Getters access and setters set or mutate. And it allows us to change an object's instance variables after the object has been created. Okay, so like if we make Scrappy and then we want to change some sort of details about him, change his instance variables, whether it's age, good dog, or even his name, we have to use a mutator method of some sort. So mutator methods are going to have these properties. They're public. They have a return type of void because they're not actually going to return anything. They just change it. The naming convention is going to be the word set followed by the instance variable name. It accepts a single parameter that represents what the instance variable will be changed to, and then there's going to be no return statement with it. So let's write the mutator methods for dog. So again, I have the instance variables here, constructors, other methods, not shown, okay? We're just going to write our mutators. And for our mutators, we're going to have one for each instance variable. So the first one for name. Public void, all mutators are void, and I'm going to have set name. And then in the parameter setting, I'm going to have string, and then I'm just going to call it n. I usually use single letters for this, lowercase letters, because that n is just a placeholder. It says, okay, I'm going to pass a value to set name. I'm going to take this value, and I'm going to put it into the name of the dog, right? So when I take that value, I need a variable to store that value. So I'm going to call that n. N catches the value, and then n is going to be put into name. And it's put into name like this, okay? So if we want to change the dog's name, okay, we call on set name, we pass it the name we want, that becomes n, and then n gets plugged into name. And we do that with age and with good dog. So age's mutator looks like this. Public void set age. Again, int, it accepts an integer because age is an integer. So it accepts, and again, I just call it a, and a goes into age. And then same thing with set good dog. Okay, this time I used word as my intermediary. Okay, so that's just an intermediary variable that's used. And when you pass data to this, it's going to take that data and then plug it in to the variable it belongs in. Okay, so this is what it looks like with our dog Scrappy. So again, I have doggy, doggy equals new dog, Scrappy. If I say doggy.setName, Scrappy do. Okay, I want his first and his last name in there. So I set name Scrappy do. Notice how I don't have a variable to capture anything because it's a void. Okay, set name is void. So I just call on this method. Scrappy do gets passed to n. Okay, n is Scrappy do, and it gets put into name. So now when I use the accessor doggy.getName, what gets printed off? Scrappy do is going to be printed off because the data was changed from when it was created. It was created as Scrappy, but then I put in Scrappy do. Okay. Mutators. So great. Okay. And that actually wraps up the end of our lesson 4. So thank you guys so much for following along. If you liked this video, please hit the like button and subscribe to my YouTube channel for more great AP CSA content. And again, thank you for watching this video, and I will see you in the next video, lesson 5. Thank you guys.